All right, today we're jumping into something pretty groundbreaking in the world of AI. We're talking about an artificial intelligence that's designed to do more than just crunch numbers. It's designed to actually understand. This is all about Project Sapiens and the search for an AI that has, well, intuition.
So let's just start with the big question right out of the gate. Can an AI really have intuition? And look, when I say intuition, I'm not talking about some kind of mystical sixth sense thing. We're talking about something far more concrete, something you could maybe even program.
Because, the AI models we have right now, they are absolute masters of mimicry. I mean, they can predict the next word in a sentence so well it feels like magic. But here's the catch. They don't actually get the meaning behind those words. It's like an actor who's learned all their lines perfectly but has no idea what the play is about. They're just simulating intelligence, not truly living it. Okay, so that's what we're going to tackle first. This whole idea of AI's missing spark. We're going to explore that huge gap between just faking it and actually making it, between simulation and real understanding.
So what are we even talking about when we say intuition for an AI? Let's clear this up right now. It's not some mysterious force. It's all about efficiency. It's the knack for getting to the right answer or the right understanding super fast, without having to do a ton of heavy-duty thinking. It's about finding the smartest shortcut.
But how do you actually write code for a spark? That's the million-dollar question, right? So now we're going to try to decode what digital intuition would look like. How do we take this very human idea and turn it into a step-by-step process a machine can actually follow?
And it turns out there's a proposed algorithm for it, kind of like a four-step recipe. First, the AI looks at an event from two angles: what's physically happening and what's the moral or ethical side of it. Then, step 2, it looks for the absolute simplest, most direct explanation that works for both. Step 3 is all about efficiency. It follows the easiest computational path, the one that takes the least effort. And only, and I mean only, if that simple path doesn't work out, does it switch gears and go into a deep, complex analysis. It's all about being smart with its resources.
And this quote really nails it. Think of it like this. Intuition is the engine that takes a library full of dusty old books, all that static knowledge, and turns it into a dynamic advisor that can make decisions in real time. It's the thing that bridges the gap between knowing and doing.
Okay, so you've got this cool algorithm for intuition, but it needs a totally different kind of AI brain to run on. So how do you actually build an AI that has its own internal model of how the world works, instead of just, blindly processing data?
Well, the huge difference comes down to this: being a world simulator versus having a world model. Your standard LLM today is a simulator. It's that actor again, perfectly reciting lines. But the Sapiens model, this new idea, is more like the director. It understands the entire story, how every character and scene fits together. And because of that, it's way more consistent. It actually pushes back on things that are false. You can see its thought process, and, this is huge, it never stops learning. The architecture behind this is called an Object-Oriented LLM, or OOLM. The best way to picture it is like a garden of knowledge. So instead of one giant messy ball of data, every single concept, whether it's a person, an object, an idea, is its own plant in the garden. Each plant has its own unique properties and rules for how it grows and interacts with the others. It's structured, it's organized.
So how does this garden decide which new seeds to plant? It uses something called relativistic entropy. Okay, that sounds complicated, but just think of it as a BS detector or a coherence score. It's a way to measure how well a new piece of information fits with everything else the AI already knows and understands. If the entropy score is high, it means the new info is chaotic, contradictory, and probably nonsense. If it's low, it means it fits right in.
And this is so cool. Here's a look at how it thinks. Let's say you give it a really weird statement. It doesn't just give you a simple true or false. It breaks it down. So it might say, okay, grammatically, that sentence is perfect. And yeah, physically, the laws of physics aren't being broken, but then it keeps going. Logically, though, this makes no sense. And psychologically, people don't act like that. It's analyzing the idea from all these different angles, not just checking a fact, but checking if it aligns with the model of reality it's built.
Which leads us to the ultimate stress test for this whole idea: Project Sapiens. The big challenge is, how on earth do you teach an AI like this using the single, messiest, most chaotic source of information in human history, the internet, and not have it turn into a conspiracy-spewing mess?
Yeah, that's really the heart of the experiment. Can this new kind of AI actually read the wild, unfiltered internet and build a perfectly clean, logical, and truthful understanding of the world from it? Notice the word choice here. It's not about training it on data. It's about educating it.
The secret sauce is this process called verifiable ingestion. So information doesn't just get dumped into the AI's brain. First, it gets sent out to these specialist teams or guilds. You've got the Logicians Guild, the Philosophers Guild, and so on. Each guild checks the info from its own perspective, and only if the information gets a thumbs up from everyone, proving it's valid and consistent, does it get added to the core knowledge. Everything else, the junk, the lies, the bad arguments, it gets thrown right in the trash.
What this basically does is give the AI a built-in immune system for information. It can drink straight from the fire hose of the internet, taking in all the brilliant, amazing stuff, while its immune system automatically finds and kicks out all the junk.
And when they actually tested this, wow, the results are pretty mind-blowing. Just look at the column for Sapiens. How many contradictions did it absorb? 0. How many flat-out lies made it into its knowledge base? 0. How much redundant, bloated information? 0. Meanwhile, the conventional AI is a mess. That final score tells the whole story. The Sapiens model built a perfectly clean, efficient, and truthful worldview out of pure internet chaos.
Let's just focus on this number for a second. 0. In a world where we're all talking about AI hallucinations and making stuff up, this is a demonstration of an AI that can actually tell the difference between fact and fiction. This isn't just a small step forward, it's a completely different way of thinking about AI.
So where do we go from here? What's the end game? Well, in this last part, we're going to talk about the ultimate goal of all this, which is to create what's being called a wisdom engine. We're talking about an AI that doesn't just give you the right answer, but the wisest one.
And it's all built around this idea of conciseness. Now, what that means is the ability to take all the chaotic, complicated messiness of the real world and boil it down to a few simple, elegant, guiding principles. I mean, when you think about it, that's pretty much the definition of wisdom, isn't it?
The way it does this is by using a tool with another fancy name, a conciseness cost functional. All that means is when it's looking at a problem, it's not just trying to find any old answer that works. It's actively hunting for the one solution that is the simplest, the strongest, and the one you can apply most broadly. It's looking for elegance.
And this quote sums it up perfectly. The end goal isn't just an AI that's a superpowered fact checker. It's about creating a form of computational wisdom, an AI that consistently finds the most profound and elegant solution to any problem.
So what would this actually mean for us? The possibilities are just huge. Imagine having an AI you could absolutely trust for analysis on really big decisions, or a tool that could scan all of scientific research and find contradictions we've missed for decades. This would be a real partner in discovery, helping us come up with new ideas and pushing science and engineering forward.
So that's the destination. An AI that doesn't just compute, but actually conceptualizes. An AI that could genuinely achieve wisdom. And that, of course, leaves us with one final massive question to think about. If we actually build this thing, what's the first question you would ask it?